Good morning, friends. I welcome you all in a series of lectures on generation of microwave signals. Myself, Mrs. Vandana Sawant, working in SIS Graduate School of Technology, and this is the second lecture on a generation of microwave signals. During my first lecture, I have introduced you that is what are the different signal generation techniques at a high frequencies, or what are the devices like solid state devices and the tubes are available. But if we go on increasing the frequency more than 1 gigahertz, then what are the limitations of these devices, that also we have seen during the lecture number 1. Now we will see that is how these devices are modified to generate a microwave signal within a few gigahertz frequency. Now we have seen like the tubes are having some disadvantages or limitations they are having, like they are having a transit time effect. So in my last lecture, in the conclusion, I have told you like that is this transit time effect can be used as a more intelligent way to in the generation of microwave signals. So we have concluded the first lecture along with these principles of microwave tubes, that is how the what are the basic principles for the making of a microwave tube. The first was transit time effect to put an advantages, and whatever the DC voltage supply given to the microwave source, that will be converted to the AC voltage at a microwave frequency by using acceleration of electrons and deceleration of electrons, and whatever the kinetic energy lost during this deceleration or emitted by this deceleration, that can be gained by an AC electric field which is generated at a microwave frequency. That conclusion we have drawn from the lecture number 1. Now we will move further in the generation of a microwave source with this. That is, we know the basic principle of a microwave tube, that it should use a transit time effect in a more intelligent way, as well as it should able to convert the DC voltage supply to the AC voltage. Now see, to do all this, there are total 5 processes gets involved in this microwave signal generation. To achieve this principle, we have to the tubes have to follow these 5 processes. Which are these 5 processes? First is the electron beam generation. That is, electron beam should be generated, that may be with the help of gun and cathode. Now once this electron beam is generated, we have to achieve a velocity modulation. Velocity modulation means changing the velocity of an electrons from the electron beam. That we will see all these processes later on in details. The next one is a density modulation. As we change the velocity, then the uniform density of the electrons in the electron beam goes on changing, and that is called as a density modulation. Density modulation is actually the result of this velocity modulation. Once the density modulation has been done, then the electrons will emit their kinetic energy, and this kinetic energy is gained by an AC signal which is present inside these tubes. So that is called transfer of energy, and once the energy is transferred to the AC signal, the electrons should be collected by some collector, that is called collection of electrons. So whatever is the type of the tube, whenever it going to generate a microwave signal, this tube has to undergo all these 5 processes, that is electron beam generation, velocity modulation, density modulation, transfer of energy, and collection of electrons. In some type of a tube, microwave tubes, all these 5 processes are carried out separately, one after another, and in some tubes they are carried out simultaneously. That is, tubes which are carrying out one after another, these are like Klystron tubes, TWT are the some examples for these processes which is to be carried out separately. In some tubes like magnetron, these all 5 processes are carried out simultaneously. So if So this will give some differentiation of tubes. Now along with this, another differentiation of these tubes, that is various tubes which are available for the generation of a microwave signal, has been done, like linear beam tubes or crossfield linear beam devices or crossfield devices, or it is also called as O type tubes and the M type tubes. Linear beam devices are also called as an O type tubes. Here the DC electric field and focusing magnetic field both are linear to each other, they are parallel to each other, so it is called as linear beam devices, and it is also called as O type tubes. Now there are some examples of linear beam devices are the reflex Klystrons and the slow wave structures, that is the TWTs are the or backward oscillators are some examples of these linear beam devices or O type tubes. While in a M type tube, the DC electric field and a focusing magnetic field are perpendicular to each other. So the examples of this are magnetron and CFA. This is a crossfield devices or M type tubes. Now see, in some tubes like reflex Klystron, all these 5 processes, either it is a M type tube or either it is a O type tube, they need to carry out these 5 processes which are we have seen already. So these 5 processes are carried out separately in a reflex Klystron. So first of all, we will see the reflex Klystron, because observing the processes separately is very easy as comparing to observing all these 5 processes simultaneously. So first we will go for a reflex Klystron. So we will first see how the reflex Klystron generates a microwave signal. Now see, this is the reflex Klystron. Reflex Klystron carries out all these 5 processes like generation of an electron beam, velocity modulation, density modulation, transfer of energy and collection of electrons. All these 5 processes one after another. So this is the easiest device to study. Now first we will see what is the construction of this device. This device is having consists of electron gun cathode, and this is cathode is given in a negative supply, okay, and along with this it consists of an accelerating grid to accelerate this electron beam which is generated with the help of electron gun and cathode. Then this accelerating grid has given in a positive supply as compared to cathode. Then there is one cavity. Now this cavity is actually the heart of this reflex Klystron. Now this cavity is called as re-entrant cavity. This cavity is called as re-entrant cavity. Now see why it is called as re-entrant, because this is a metallic cavity here, and here there is a loose cavity, and again there is a metallic cavity. So cavity, loose cavity, and again cavity. So this type of structure is called as re-entrant structure. This type of structure is called as re-entrant structure. This cavity will act as a resonating cavity or resonator. This is also called as cavity resonator. That means it will have some resonant frequency, and whatever the signal present inside the cavity, that will resonate at particular that resonating frequency. Now this cavity will have the resonant frequency in microwave range, that is above 1 gigahertz. So this is called as a resonating re-entrant cavity, which is resonating in a microwave range of frequencies. This cavity is supplied with a positive voltage. This cavity is supplied with a positive voltage as compared to cathode. So it may act, or it will act as an anode. It will act as an anode. This is a cathode, this is accelerating grid, this is a anode. Along with this cavity, there is another one electrode is present, that is called as a repeller. It is placed at a particular some distance from this cavity, and the distance in between the cavity and repeller is called as repeller space. So it is kept at some distance from the cavity. The distance is called as a repeller space. This electrode is indicated or denoted by an R. Now this repeller voltage is given and a negative supply as compared to this cavity, so this is the construction. It consists of an electron gun, cathode, accelerating grid, then re-entrant resonating cavity, and the repeller voltage. So now one by one we'll see how all these 5 processes are carried out in this tube. The first process is the electron beam generation. Now see, here we are having an electron gun and we are having a cathode. Now this assembly, electron gun and cathode, is responsible for producing a electron beam. It is responsible for producing a electron beam, because cathode is supplied with a negative supply and electron gun is supplied with a DC electric signal. So because of this high electric field, cathode emits the electron and this is result into the electron beam. Now this beam which is emitted by a cathode or generated by a cathode, this will get accelerated by using this accelerating grid. It will get accelerated by using this accelerating grid. Now this electron beam will travel in a forward direction towards the anode. Here resonating cavity is acting as an anode. So this electron beam will move in this way towards this resonating cavity. When this electron beam reaches to the resonating cavity, then what happens? Like, there is a loose cavity. As there is a loose cavity, there is no metallic thing to stop these electrons. So because of this loose cavity, the electrons will pass from this loose cavity and goes towards the repeller. But repeller is having a negative voltage. So as the repeller is having a negative voltage, it will not keep the electrons with him. So what it will do? It will reflect these electrons back. Now these back reflected electrons will come again to the cavity. But while coming back, they are following the path like this. This is the electron trajectory. So why this trajectory is happening, or why they are following path like this, and why they are coming exactly at this point in the cavity, that we have to see one after that is explained by using all these 5 processes one after another. We will see. Then this is the electron beam generation, and this is the general process when there is no any signal is here. That is whatever the electron beam generated, that will pass from this loose cavity, goes towards the repeller, get reflected back from the repeller. But see, this is not only the thing. There is one component, that is this resonating cavity is present here, that will not allow the simple processing, or it will come in a picture, or here the transit time effect will take place, and that is responsible for generation of a microwave signal. Okay, now we will see what happens there inside this cavity. Inside the cavity is supplied with a high positive voltage. Now as this cavity is supplied with a high positive voltage, because of some noise which is present, some amount or small AC signal will get generated inside this cavity. As this AC signal gets generated inside the cavity, this cavity is in a resonating cavity. As this cavity is in a resonating cavity, the frequency of this AC signal will be equal to the resonating frequency of the cavity, and this cavity is resonating at microwave frequency. So what will happen? Whatever the signal generated inside the cavity, that will resonate at a microwave frequency, or the signal which is generated, that will have a microwave frequency. So this microwave signal frequency signal which is present inside this gap. So what will happen? The electrons are continuously coming from this cathode. and these electrons will come in contact with this AC signal which is present inside this cavity gap. Now when the electrons come in contact with this AC signal, they will get affected by the AC signal. So there are basically the three positions on which they will get affected, or we can differentiate into the three positions, like position number A, that is highest positive peak of the AC signal. Then position number B, whenever the AC signal is equal to 0, and position number C, whenever the AC signal is at a highest negative peak. So we can call the electrons which are encountered here as a electron A, electron which is encountered here as a electron B, and the electrons which are encountered here, that is electron C. Now this A, B and C are the three positions which are responsible for the next process, that is the velocity modulation. Now we will move to the next process, like velocity modulation. Here what happens, as the electrons come from this cathode and accelerating grid at a point A, that we are calling as an electron A. At a point A, there is a highest positive peak. So what will happen? The electron A will get accelerated by using this highest positive peak, and the velocity of the electron will be increased. To the highest possible amount. As the velocity increases, it will penetrate more in this repeller space. Then when it goes to the repeller is a negative electrode, so it will not keep the electron with him. It will reflect back this electron. And the electron will follow such a path. Similarly, what happens, the electron which is reaching at a point B, that is called as a electron B. This electron B is encountered with a 0 voltage. So there is no change in the velocity for an electron B, and it will travel with a normal velocity in a repeller space, get reflected by a repeller and come back again to the cavity. Then the electrons which are encountered at a position C, that is the electron C. So this electron C will get affected by an highest negative peak, that is the lowest possible voltage. So what will happen, because of this negative voltage, the electron will get decelerated. So because of deceleration of this electron, what happens, the velocity will get decreased. And as the velocity decreases, it will travel little in the repeller space and get reflected back from the repeller. Now see, electron A is having with highest velocity or traveling with an highest velocity started earlier. Electron B traveling with a normal velocity started after A, and electron C which is started after B with a lowest velocity. So if we see all this, like electron A started earlier, highest velocity, electron C started at the last and having a lowest velocity, then they will travel for some distance and meet with each other after some distance. So that is called as, also because of that, the result is the bunching of electrons will take place at some distance. If they travel for some distance, they will meet with each other and their bunch is formed. So this encountering of the A, B and C positions with an electron beam, changing the velocity of an electron beam, is called as a velocity modulation. And as a result of this velocity modulation, after traveling for some distance, the electrons will bunch. Electrons will form the bunch. That is called as bunching of electrons. Now see, initially whatever the electrons, these electrons are uniformly spread out. That means the density will be equal throughout the space. But what happens, so because of this bunching, the density will get disturbed, So we can call, because of this bunching, we can say that the density will get disturbed or density will get changed. So that process we can call it as the density modulation. So we have seen how the electron beam generated, then how the velocity modulation takes place, and as a result of a velocity modulation the bunching will take place, that is called as density modulation. So now because of this density modulation or because of this bunching, the electrons which are reaching to the cavity, their velocity, because of this bunching the velocity gets decreased. As the velocity, they want to settle down somewhere, as the velocity decreases they will emit their kinetic energy or they will lose their kinetic energy. Now this lost kinetic energy, we know that the energy can be transferred only. Okay, so this lost kinetic energy can be catched by this AC voltage, or there is one fellow who will able to catch this lost kinetic energy, that is this AC voltage. So this AC voltage will catch this lost kinetic energy, and the AC voltage, the strength of this AC voltage will goes on increasing. Now this lost kinetic energy will be catched by an AC voltage, strength goes on increasing. As more and more number of electron bunch comes to the cavity, the more and more energy will be catched by this AC voltage, and strength of the AC signal goes on increasing. But when the highest amount of AC signal will be catched by this highest amount of energy will be catched by this AC signal, that will take place at 3/4 position of the next cycle. So we have to adjust the repeller space and the voltage given to the repeller in a such a way that whatever the electrons which are coming back to the cavity, they will come back to the cavity when there is a positive peak of the next cycle. That is, after 3/4 cycles, electrons will come back to the cavity. Then and then only the maximum energy from the electrons will get extracted by this AC signal. In this way, we can increase the strength of this AC signal. So as more and more number of electrons are get velocity modulation, undergo the velocity modulation, then as a result of velocity modulation the density modulation takes place, and more bunches will reach to the cavity. As more and more number of bunches will reach to the cavity, then a large amount of energy will be catched by an AC signal, and the strength of this AC signal goes on increasing. Now see, if the power delivered by this bunch of electron increases more than the power lost in the cavity, then sustained oscillations inside the cavity will takes place. Okay, whatever the losses, if the power delivered by this electron is more than the losses occurring inside the cavity, then the sustained oscillations are generated inside this cavity. Now this sustained oscillations which are generated inside the cavity, the strength of these oscillations goes on increasing as more and more number of electron bunches are reaching to the cavity. Now this signal can be connected to the output. This signal can be connected to the output with the help of small loop with a central conductor of coax. Now this is a small loop, this is an output side. Here the small loop is there, and this small loop is having a central conductor of coax that can be used to extract the signal from this cavity, and this power will be taken out from the cavity and it will be given to the amplifier, or it can be given to generate an oscillations or filters, whatever the signals you want to, or whatever the circuits you want to work upon this microwave signal, you can connect this power to the circuit. In this way we can generate a microwave signal by using a reflex klystron. Now see, in this reflex klystron, the maximum power will be outputted when this bunching of electrons will take place very close from this point B, that is highest positive peak from this point B. So the highest power will be available at this first peak, and the next power is available at this second peak. But at the first peak we are having many problems with catching with this power of processing of this signal, like we can get disturbance in the signal. So it is always preferred like that is the power should be collected at, or bunching should be collected in the next cycle, 3/4 peak of the next 3/4 of the next cycle. So that will be, we can get a fair power and clear signals from here. And this varies the bunching, where the bunches are reaching, at which peak they are reaching, that is called as modes of operation. That is called as modes of operation for this device. In this way we have seen the reflex klystron, how the signal is generated. In brief I will explain once again, like there are 5 processes are involved in the reflex klystron within a generation of for the generation of microwave signals. All types of tubes has to follow these 5 processes. The process number 1 is the electron beam generation. Electron beam generation can be done by using an electron gun and cathode. This assembly is here. Now once the electron beam is generated, it is accelerated by using this accelerating greave. Then after acceleration, electron beam reaches to the cavity. When it reaches to the cavity, it will undergo the velocity modulation. This cavity is a re-entrant cavity, because here it is a cavity, here it is a loose cavity, and again cavity. So this structure is called as a re-entrant cavity. Then because of this high DC electric field, the noise voltage gets generated inside the cavity, and this is in the form of AC voltage having the same frequency as a resonating frequency of the cavity, and this will affect the electrons. So because of these electrons, they will get velocity modulation, undergo the velocity modulation. Velocity modulation means changing of velocity of these electrons at point A, B and C. So all these electrons will undergo the velocity modulation. Velocity will change at point A highest velocity, at point B normal velocity, at point C lowest velocity. That is called as velocity modulation. So because of velocity modulation, they will penetrate. If the higher velocity electrons will penetrate more in the repeller space and get reflected back from a repeller space, and lowest velocity electrons will penetrate very small distance in the repeller space and get reflected back from a repeller. So because of this velocity modulation, result will be the bunching of electrons. This bunching of electrons is called as density modulation, and these bunch are catched by the 3/4 of next cycle of the AC signal, and that can be, this catching position can be achieved by changing the repeller voltage or adjusting the repeller voltage as well as the repeller space, so that we can extract the maximum power from this bunch of electrons. So this power given by the bunch of electrons will be catched by an AC signal. Maximum power is catched, and once this power increases more than the losses occurring inside the cavity, then the sustained oscillations of the microwave signals are generated inside the cavity. These sustained oscillations are taken out by using RF probes or RF output systems. Here the small loop is used, which is having a central conductor of coax, and it is connected to the other devices. Thank you.